Hello everyone, we welcome you for this video to learn chemistry for the NEET examination preparation. So first I want to start with the first chapter, the basic concepts in chemistry. And since it is a physical chemistry chapter, most of you will try to avoid solving the problems, but actually it is very easy to solve the problems in the physical chemistry. And in first chapter, one important concept where you frequently get questions is from mole concept. So mole concept, you know the formula, the number of moles of any substance can be calculated. So using the mass or the given number or by the volume. So using these formulas, it is given mass by the molar mass or the atomic mass. It is a given number divided by the Avogadro number and a given volume divided by the molar volume. So these terms will give you the number of moles, and using number of moles we can solve many problems, so which is frequently asked in most of the competitive examinations. So we will try to solve some of the problems. So first problem, so it says that the number of atoms in 558.5 grams of iron is, and I have given the option not as a number, but you can see the option. So it is given as a statement. So first it says that twice out of 60 grams of carbon, and we can easily solve this, so no need to get into the formulas and all those things. So listen, 558.5, we know 1 mole of any substance, it contains the Avogadro number of atoms. So you try to correlate only the mass with the number of atoms. So iron, the mass of iron, they have given it as 55.85 grams. 55.85 grams says that it contains Avogadro number, then it means 558.5 grams means. So you can easily solve, no need to look into the formulas and all. So you can easily solve using the simple direct and indirect variation in mathematics we have learned. If the mass increases, obviously the number of atoms will also increase. So 55.85 increases to 558.5 by multiplying by 10. So it says that it is 10 times that of the Avogadro number. And when you look into the option, it is twice out of 60 grams of carbon. So mass of carbon is 12 grams. So 12 grams contains Avogadro number, and it is 60 grams of carbon. So it will be, you have to multiply this by 5. So it is 5 times of the Avogadro number. And the option says it is twice that of the 60 grams of carbon. So 2 into 5 times of Avogadro number, which is nothing but the 10 times of the Avogadro number. So from this, it is clear that the option A is the right answer, because the 558.5 grams of iron is correlated to the twice that of the 60 grams of the carbon. So the second type of problem, so it says that what is the maximum number of molecules which is present in the following. So first question, so it is asked, so what is correlated to the particular mass? And the second problem, it correlated to what is the maximum number of molecules which is present in the following. Again, we have to go for the mole concept, and you know the mole concept has 3 formulas. Again, you have the haphazard feelings, whether which formula we have to use, no go into all those things. We can simply calculate this using the same direct and indirect variation in mathematics. So it says 44 grams of carbon dioxide, and the mass of molecular mass of carbon dioxide is 44. So 44 grams contains 1 mole of the substance, which is nothing but the Avogadro number of the molecules. And again it is 48 grams of ozone, and the molecular mass of ozone is actually 48. So 48 grams means it is again 1 mole, so which contains the Avogadro number of the molecules. Third option says that it is 8 grams of hydrogen, and we know very well hydrogen, the mass of molecular mass of hydrogen is actually 2 grams. Here you have 8 grams, so it is 4 moles, which means that it is 4 times that of the Avogadro number. And 64 grams of sulfur dioxide, the molecular mass of sulfur dioxide is 64. 64 grams contains the 1 mole of the substance, which is the Avogadro number of molecules. And so these simple calculations show you 8 grams of hydrogen, it contains more number of molecules. So similarly, so we have so many problems, so the same type of patterns. Similarly, so you can work it out this problem and find out so which contains the maximum number of atoms. Thank you for watching.